Hello, everybody. Let's get started. Is there somebody present who would be so kind as to capture notes for us? I see a hand. Thank you very much, Rob. And if anybody wants to watch Jabber and bring anything to the mic, that would be cake, but we're not going to hold up the meeting for it. So we have an hour to get a fair amount done, so let's get started. First order of business, welcome to Bruno, who's already been very productive as a co-chair. The note well, which you've no doubt already noted well, but yet we still should keep it in mind. In particular, we were recently reminded by the 6-man people that IPR disclosures early and often are very important to maintain good relations with all our neighbors. So we should, anyway. Right, so we wanted to talk some about our charter, how we're making progress towards it, and we spent some time, Bruno and I spent some time looking at our actually quite large zoo of drafts that we have and trying to figure out how are we going to make progress towards progressing Spring's charter and what happens next. So here's a few quotations from the charter, and we took them and tried to map the drafts that we have, or map these, sort of high-level, this is what you are chartered to do items onto our milestones in the charter and onto the drafts that we have either already adopted as working group items or individual drafts that appeared to us that they may be candidates for satisfying one or more of those working group items. And I'll also point out that there are other drafts, some that were brought quite early, some that are continuing to arrive, that while they may be very good and laudable work, don't actually advance our charter. And what you'll find is that we're going to say, we're really hoping to focus on the charter. We're hoping to focus on advancing the charter. This means adopting sort of the minimum necessary set of documents to move the work forward, and not possibly every single draft that's in existence. And that's not meant as in any way as a judgment of anybody's work. This happens in the IETF all the time. So our first point from the charter is charter to identify and evaluate use cases for Spring. They must include a definition of the data plane for the environment in which they are to be deployed. And then we have a milestone. You'll note that many of these now are in the past despite our best intentions. So one of the things that the chairs will be doing fairly soon is going and putting new dates on the milestones that are in the future. One or more documents describing Spring use cases. So we have obviously 3 adopted working group items, and then there's a number of other use cases listed here. And I said it on the slide, I didn't talk over it, but we just made our best effort at binning these things, okay? So if we got something wrong, tell us now or later or whatever, and we'll fix it. This is just our kind of first pass at rationalizing the charter and the milestones. Right. So of these, problem statement is kind of the big one. And we did complete a working group last call, and we were awaiting a couple of administrative things, and I don't wish to find fault with anyone at all, although if there's a fault to be found and it doesn't go to anyone else, I suppose it goes to the chair. So there we go, mea maxima culpa for not chasing down the necessary people and saying, we need to make sure we get all the IPR statements made, and we need to get the necessary revisions made. I think that we are now on track to have this done fairly soon. There's a document update necessary. Stefano has the comments and says that he's just probably on his flight home, he'll have plenty of time with his text editor. I just made that up. Okay, then the kind of big item, because I had to break it into 2 slides, is the second thing from the charter, data plane encodings. So we're chartered for definition of requirements for any new data plane encodings and procedures required to implement the use cases. Procedures must include the necessary security considerations. So we have a high-level abstract architecture that's adopted. And then we've got several NAs here. Requirement for modifications to MPLS architecture. We think that there basically are none. Requirements for modifications to V6 architecture. I will say that, yeah, anyway, there either are none or they're captured in the main architectural document. Let's see. Specification of any required new procedures to support Spring use cases. We have nothing mapped into that right now. One or more data plane extension requirements documents, including documenting the impact on existing deployments of the existing data planes. Yeah, so to some extent, these requirements are maybe implicit in the architecture and the data plane extension documents. And then we've got this other small pile of drafts that may be applicable. Control plane. So this is not quite such a wall of text, but definition of requirements and if necessary, any new control plane mechanism needed to enable the use cases. So extensions requirements documents, gosh, we just jumped right over that, and have a whole lot of documents in virtually, well, maybe not quite every other routing working group, but a lot of other routing working groups. And I think that one of the things we'll have to do is decide which of these we're tracking as working group items, because what we've tentatively agreed to do is that we're not going to try to create new working group items for any of these milestones. We're just going to say, look, over there in ISIS, they're doing segment routing extensions. We'll track that. Once we've cleared, you know, ISIS and OSPF and whatever else we decide to track, then we will say that our milestone is complete. And definition of requirements and, if necessary, management plane mechanisms needed to manage and operate a Spring-enabled network. So we have notably no adopted working group drafts here. And I'm going to say, do we have even any working group drafts in any working group? I don't think so. This is probably going to need to be a focus going forward. Not in this meeting, but, you know, soon. Then we have a milestone for documenting interworking and coexistence between new procedures and existing. So basically, you know, how do we deploy this thing? So we do, again, have some work that exists here. Again, it's not adopted as working group items. And again, we're going to need to apply some focus on this in a future meeting, not this one. And then this is, yeah, almost the last slide. And we're almost on time. So the initial data planes to be considered are MPLS and V6, and so far the only, and I kind of hope, the initial and complete set of data planes, because that's enough. So these two V6 related drafts were presented to 6-man on Monday. Bruno and I just finished having a meeting with the 6-man chairs and the relevant ADs to talk about, you know, what's our way forward, and kind of agreed. You know, the 6-man chair said, well, look, guys, we would like to know that your architecture is well enough nailed that it's not going to shift under us if we start adopting this routing header that you've brought to us. You know, we don't want to adopt a routing header and then find out that nobody really knows what it's for. So give us some confidence that you know what this routing header of yours is for. I said, okay, how shall we accomplish that? And what we agreed to is that the architecture document shall be last called, you know, cross last called in 6-man, so that 6-man can give it some review and be aware that it's gone through or is going through last call. Subsequently, the V6 extension documents themselves shall be done in 6-man, but it is important, and I will say, crucially important for anyone in this group that cares about the V6 data plane and how it's specified, to participate on, in the 6-man list and meetings, because it's not their, general bailiwick, and well, hopefully the reasons are obvious why your attention is necessary. So, sign up for the mailing list now, why don't you? So what's our plan moving forward? We need to update the milestones. We need to work on mapping the, figuring out what drafts are going to maybe fit underneath which milestones. This may also then turn into a bunch of working group adoption requests. Though I think that probably the first thing for the group as a whole to focus attention on is trying to move the architecture document forward, since it's gating the V6 work. Yeah, and I think that I pretty much talked over all the rest of this. So we're now 3 minutes behind where I was hoping to be. And I will invite Stefano to come up and talk about where we are with the working group drafts.
Okay, hi everybody. My name is Stefano. A small update on the different segment routing drafts. What do we have there? The main one, called the architecture draft, which has been updated with the last comment that we received. We didn't get any other comment or claims after that, so I suppose it's ready to go. The use cases, I think it has been updated recently with some minor stuff there, so it's also pretty stable. As John said, also about the different IPv6 segment routing draft, the protocol extensions are being discussed now in 6-man, and finally we got some discussions there, so feel free to join the 6-man mailing list to contribute to the discussion. The routing MPLS, segment routing MPLS, data plane, no changes, pretty stable. Probably needs some cleanup just to refresh some sections, but mostly the content didn't change. So it's also pretty ready to go for last call. Same for the problem statement, except that there are a bunch of comments, my fault, that slipped away from my to-do list, so I have to update it. The comments from Alvaro. So after this round, it should be also quite stable. The resiliency use case, I think it didn't change, at least for the last 4 months. So this is pretty much it. Next, if there is a next, yeah. So the big one is the segment routing use cases draft. That, in fact, it has been the first segment routing draft that we submitted a little while ago, that contains the description of all the use cases that we want to address with segment routing and how to address them with segment routing. Then part of the content of the use cases draft has been used and moved into the problem statement draft. So there is quite a bit of text application in the use cases draft that needs rework and clean up. But there are sections that are pretty useful, I believe, that should be kept somewhere, especially all the description on how to use segment routing for traffic engineering. And this section will probably, we will rework it a bit, refresh the draft, probably rename the draft to be more specific to traffic engineering. But we would like this draft to go to the publication process, so we will resubmit it as a segment routing traffic engineering use case or something like this. The segment routing LDP interrupt draft, very stable, describes how to interrupt between segment routing and LDP. The protocol extensions for doing this are described in the OSPF and ISIS drafts. We have multiple implementations, and they're also interoperable, surprisingly, but yeah. So clearly, that draft, the authors would like now to see the adoption as working group item because it really represents the use case and the reality of the implementations. Then we have the two BGP-based segment routing draft, the MSDC and the Central EPE. Both described only the use cases, and in IDR we have the corresponding protocol extensions draft. So the prefix SID in one draft, and the BGP-LS extensions for EPE on the other one. We received little comments. They are pretty stable. I think they're a pretty good candidate for adoption as working group item as well, so that's what we request. And finally, the segment routing TI-LFA, which is the segment routing solution for the resiliency. The resiliency use case being obviously described in a different document. I don't know, I mean, talking with the chairs, we have to decide if this is the right place for the TI-LFA draft, or should it be moved to the routing area working group? I don't know.
Yeah, so I can say I had just a few words with Jeff, and he thought that routing area would be an appropriate place, and I think both of us think so too. So
fine.
If that's, unless anybody has any objection, that would be where we would suggest pursuing it.
So in conclusion, we would like to have the LDP interop, the BGP segment routing drafts adopted as working group item.
Yeah, so of course we'll do that on the list.
Yep.
Rob, if you wouldn't mind noting that in the minutes, though, so we don't walk out of here and immediately forget. Thank you.
Okay. Questions? Thank you.
Greg?
Okay. Next. So this is update on our progress since last IETF meeting. We received very good comments and appreciate input from law. We worked together with their authors of other draft that was, and now welcome Mac Chan to work with us. And we added one use case and consideration for processing return when there is no requested return path available. Next. So this is a more detailed description of that scenario when their far end receives their return path TLV and cannot find. There are two options that we suggest. One option is that if far end follows RFC 5884 and establishes BFD session reverse direction over IP domain, according to 5884, it has an option to use LSP echo reply to send back report. Then we state that in that case it may use a return code couldn't find their reverse path to clarify the situation. If their egress does not want to decide by implementation choice or by operator choice or implementation establish return path over IP, then it must use and send back echo reply and must use error code that we introduce. We can go next. And then sorry. Yeah, no, it's my fault. I know. It's my fault. It happened already with other presentation. It just, line's too wide. So it should be all boxes around these letters, and they're interconnected as a ring. Yeah, I can see it from here. No, it's just, yeah, sorry, it's a poor choice of graphics. So the idea is just to illustrate that what we can do, because if we imagine that we have tunnels A, B, C, D, G, and H, and then we have A, B, E, F, G, H, and then we have tunnels in reverse direction, then we can do monitoring of each path in a bidirectional correlated manner by instructing their node H, because we can do it for the same fact as we now clarified 5884, that there could be multiple BFD sessions to the same fact using the different discriminators. So, and using explicit return path TLV, we can direct the return path over HGDCBA in first scenario and HGFEBA in the second case. So we already made a presentation at MPLS working group and asked for the working group adoption, and so it's will be considered, and probably, hopefully by Prague, we'll have a new working group document at MPLS working group. Comments always welcome.
Thank you.
Hi, folks. So the talk is about segment routing Yang model. So you can skip the two next slides.
1, 2.
Yeah, good. So this is the overall model structure that we are currently proposing. So it will address both the configuration and operational states for segment routing. Here you can have a view of the overall global configuration. And the interesting discussion we are expecting is that today, in all implementation, at least that I know, the segment routing configuration is part of your routing protocol, so ISIS or OSPF or what is existing today. And the main point is it the right design? And based on some discussions that we had within the co-authors, we don't think this is the right design. Because if you have a network which is composed of multiple protocols, BGP or mixing OSPF and ISIS or whatever, so some parameters sounds critical to be global. And especially, for example, the segment routing global block, so sRGB. So we are proposing a segment routing model that is directly attached to the core routing model within the routing instance. So we can also discuss if is this segment routing model, must this segment routing model be attached to the routing instance, or is it also more a chassis-wide configuration? This is something that we need also to discuss. So you can see here, so we are able to configure multiple sRGBs. We are able to configure what we are calling the mapping server. So for example, via SRLDP interop, and also the transport type. So in the standard model, we are proposing only MPLS as a data plane for the moment, but if someone wants to do this fancy IPv6, it can add it using augmentation. Next slide.
Do you want to take questions now, or?
Can you wait, or? Go ahead. Good. Do you think you may need
Can
to...
people in the back of the room tell me, is the mic picking Uma up? Okay.
Okay.
Yeah.
Okay. do you think you will need to advertise different entries if you have different IGPs? In my point of view, at least, but maybe I'm wrong, I would try to have something that is consistent within my routing, so advertising exactly the same binding within all my routing domains. It's not working also. Come on.
Is it okay now?
Yes, better.
So my question is about associating this policy or whatever the mapping server entry to the IGPs actually. That's where you need to give a name so that you can easily associate this whole thing in a particular IGP instance. I can discuss offline.
Yeah, maybe we can discuss because I'm not sure about what you are trying exactly to achieve. Yeah.
Stefan, my comment goes actually in the same direction, right? I mean, the mapping server functionality could also get implemented using routing policy, right? Think about it.
Yes,
if
you
you're
can.
taking LDP routes, labeled BGP routes, and essentially all what you have to do is to attach an index to it and sort of feed it back to the routing agreement.
It's possible to see it like this, but not all the implementation are considering LDP as a routing protocol.
Mapping server defines the export policy between the LDP cloud and the IGP cloud.
Right.
Did you sense the word policy here?
Policy makes sense. The main question is about when you are trying to perform a routing policy within a routing protocol, you are interacting between routing protocols. And some implementation are not considering LDP and just LDP as a routing protocol.
I see, because...
That's just my point. Okay. But I agree about this. Okay. This can also be expressed as policy, but there may be more discussions. But I'm open to discuss about this configuration.
Probably we can talk it offline, but probably when you define those mapping server table, we can just give it a sort of policy name, default or whatever, and then all the vendors should be able to find a home here.
Why not?
Okay.
So,
Robin from Huawei. One thing I wanted to be clarified. In this model, this is specified to configure node or configure
node.
I'm
configuring the router to perform segment routing.
Yeah, I think that this is the object is configure the segment routing on the node. That's my
right.
But this is the mapping server. You means because I think the mapping server may be a different object from the node.
No.
You mean they are same?
You are configuring the mapping server on a node. Where do you want to configure it?
Because here that is a lot of binding of the prefix, and this is the node.
I think you guys are using the term mapping server differently.
AC Lindum. I think the thing is here, if the node is not the mapping server, you don't configure it. This is for the local, this network device and this routing instance, because it augments routing instance, is the mapping server. It's an SR node, segment routing node, and the mapping server.
Right. Okay, so my question is that so there are always a mapping server in the network, segment network?
No, if you don't need the SR LDP interrupt, you don't
use if there's no mapping server in the network, how to configure a node address to bind in the segment ID?
So yeah, I'd like to ask any further questions be held until the end of the presentation, please.
Overall. So this question about where the segment routing configuration should be for each parameter, this is something that we need clearly to discuss between us. Next slide, please. So here is the interface configuration. So within the interface, we have two kinds of segment routing parameters. The first one is about the handling of the adjacency segment. So do I want to advertise this adjacency segment for this interface, and also the ability to add this to manage the different flags that we have in the adjacency segment. So being able to say, I want to advertise the protection state for this adjacency, or saying I want to advertise both a protected adjacency segment and a non-protected adjacency segment. We are also providing some facilities to perform bundling and advertising using the S flag single adjacency segments that will be shared by multiple interfaces to facilitate the load balancing. We are also proposing the configuration of the prefix segment ID. So for the prefix that is attached to this interface, we can configure the prefixed value. We can do it. We propose two flavors, index or absolute values, and we can also define if this prefix segment must be considered as a nodal segment or if it's just a prefix segment for both IPv4 and IPv6. Next slide. So the bundling. So this is something that is not really clear today in the specification. We are defining in the encoding the S flag, but we don't really know how to use it. So here we are doing some proposal about how to use this S flag and to permit easier bundling and facilitate ECMP. So the idea that we have and we could discuss on is to set a group ID for each interface, and all the interfaces that will be part of the same group ID, in addition to their unique adjacency segment, they will advertise a common adjacency segment that will permit the ECMP. Next slide. So now, in terms of protocol extensions, so we are defining here the global segment routing configuration, but then we must interact with routing protocols to say, oh, okay, I have an ISIS protocol, I authorizing the advertisement of the segment routing extensions. So we are proposing here to augment ISIS and OSPF Yang model to manage these segment routing extensions. Next slide. So here we still have also to discuss, is it the right way to do this, or do we need to manage all the configuration directly in the ISIS and OSPF model? Currently, we also have some segment routing container within ISIS because we don't really know the good way to do it, so it will be up to discussion. Next slide. So here are the operational state, not really readable, I think. But the important point that we are giving here is the ability to monitor the usage of the sRGB, how many labels are free, how many labels are used, and also giving some information about all the bindings that are currently in use. So bindings that may come from mapping server, and also bindings that are directly learned from the prefix segment, for example. We have also some very, I think, mandatory for the operations notifications that will permit to alert, for example, when you have some collision of segments or some stuff like that. Next slide. So the next step. So this segment routing Yang model is coming from discussions that we have within ISIS and OSPF Yang model. So most of the people that are involved in this work are coming from the ISIS and OSPF model. It's quite, I think, accurate in terms of feature compared to what is shipped today in the operational codes. It's clearly time to work on it because codes are currently just shipped or under shipping, so it's time now to try to think on a common way of configuration for segment routing. So for sure, there is a lot of things that we need to discuss. So the sRGB scope, how to handle the interactions with ISIS and OSPF, and we are clearly welcoming all the comments on this part to ensure that we are all in line on the way to model it. And we think that this is a really important work, so we ask working group adoption for this document.
Okay, thanks. Any further questions or comments? Please keep them short because we have a short time on our agenda.
Shraddha from Juniper. So I have one question on the interface level config. I think you have the interface level configs also in the global model.
No, it's the same, in fact. It's
under
hierarchical.
global, you
It's
also
hierarchical, so you have the segment routing container, which is attached in the routing instance, and within this segment routing container, you have global parameters and you have per interface parameters.
Yeah, so I think it's unusual to configure interfaces at the segment routing under global segment routing option. I think it's more appropriate to have it under the protocols.
But which protocol within each protocol?
Each protocol. Yes.
So you may think that you will advertise a different segment ID if you have, for example, OSPF and ISIS under the same interface?
Could be.
I'm open, but for me it didn't make sense, so that's why I proposed this, but we can discuss.
To me, it looks like it's unusual to do global configurations for interfaces because
you may consider that segment routing as a sort also of routing protocol. Even it's not a routing protocol, it's a kind of routing stuff. So as for ISIS and OS, this is my okay.
Yeah, I'm sorry, but we've got a bunch of people at the so no more people coming to the lines, please, and keep your comments relatively short.
Sri, go ahead.
Sri Ganesh from Ericsson. So are you also planning to model any of the hardware capabilities that affect segment routing in this model?
Maybe it should be interesting, especially for the entropy label stuff.
Yeah, because if I see the PCEP,
yeah,
if I see the PCEP segment routing, I see hardware capabilities that might be useful in this model.
Okay, Pushpashish, Juniper. So I'm a co-author in this, but still I think a container both at the global as well as the protocol level will actually suffice a lot of usage. So what I'm trying to say here is that you may have one configuration under global and do not put any configuration under protocol level, so all protocols take that. But you can override that on a specific protocol level.
Yeah, for sure, using groupings, it would be quite easy to do.
Yeah, I think that is a better model, I think.
Hey, AC, what about cutting the lines? Didn't you understand?
I did. Well, I'm an offer, so you can't.
Oh, well, that's all right then.
Yes, okay. No, we'll make it a container that could be augmented by a particular implementation.
Yeah.
This is Uma from Ericsson. I feel some of the configuration like mapping server, which are common to both IGPs, should be in the global sRGB segment routing, and some of the protocol-specific stuff should be in the IGPs only.
Maybe,
I think
but
we should
need to decide what
yeah.
is exactly the need.
I think
it should be our discussion, maybe.
I'll take it offline, but you cannot put everything on the...
Sure, completely agree.
Thank you very much.
Hello. Okay, this is another young data model for segment routing. So I'm Fang Wei from GT. So the goal is to define the segment routing young data model. So next. So here is the configuration hierarchical. The first node is the global node. Here is the sRGB. It's the same with Stanford's young data model. And another is segment. Here we define segment node in the global in the global venue. And I think this is more flexible because we can define different type of segment. And the third leaf of the segment node is the type. Here we define the type as a prefix segment or adjacency segment. Maybe other type of segment in the future. Next is the scope of the segment. We define the scope, maybe local or global scope. And the next is the prefix and adjacency flag. And the third node is the FEC mapping, where we define the FEC prefix to a SR path. So the next tool is the SR, is the get operation. We define the SR neighbor entity and the SR path. For the SR neighbor entity, we define SID incoming and outgoing interface and next hop, and some more header operation, egress interface. For the SR path, we define the name, ingress SID, egress SID, and the priority, and the expensive route, and the path type. Here the path type we define two value, the master and the slave, so it can be used for FRR. And the last one is FR protection method. We define node protection or linker protection. So this is a configuration architecture for our data model. So next is notification. We define the SR path event, where the event may be segment routing creation and the segment routing path deletion, and the path state change, and the FR status changes. And also we define path protection status change. So this is the data model design. Next slide. So we received some comments. The first is from Rebel. He suggested we add SR MS node, so I think this is okay for us. And another, we have an offline discussion with Stanford, the first young data model, and Stanford and AC. So they suggest that some of the TE related nodes and the forwarding neighbor nodes should be augmented from MPR's TE model or MPR's model. So I think this is reasonable. So this is my first try in young data model. So I think we can do more research in this area based on our product implementation. So comments.
So I have a comment for the authors of both drafts, which is it doesn't seem likely to me that the working group will ultimately adopt two drafts. So if I encourage you all to work to improve one of the drafts and move it forward together.
Yeah.
So maybe you can take some time after the meeting, or talk among yourselves. But I would encourage you to find some way to move together with one work if you can.
Okay, thank you.
Hello everyone, this is the entropy label for segment routing MPLS draft. So this draft has just become a working group document in the MPLS working group. It's about 2 or 3 weeks old as a working group document, and I'm going to update on the changes that have happened since the last IETF. So as a background, this is basically for load balancing of segment routing, specifically for the MPLS data plane. And specifically it's about how to use RFC 6790, which is the entropy label RFC for segment routing. So the main change that we have done is addressing the MPLS RT preview comments. There were a few of them outstanding. And as a part of addressing those, what we have done is we have changed the use case The previous version of the draft used a service chaining use case with service SIDs. So we have changed that totally to a traffic engineering use case using only node SIDs and adjacency SIDs. And the readability of the sample algorithm provided to compute where the entropy ELI and the EL needs to be inserted has also been improved, and all the examples have been updated with the new changes. Next slide, please. So this is as bad as the previous one, but slightly better.
Is that any better? Not really, huh? Any better
Not
at all?
really. Not really. Yeah. So I'll try my best. So essentially the use case, this is the topology for the use case where the packet has to go from S to D. There are parallel links between the LSRs P1 and P3 as well as ECMP paths between P2 and destination. So the constraint for to route the LSP is that it should go through a specific link L1. And for that, normally it would take 3 labels for the label stack. Now the node P1 has a restriction that it can read only 4 labels on the label stack. So when you have a 3-label label stack and you insert a ELI EL, essentially the EL is too deep for P1 to read the label stack and do good load balancing. So essentially there are a set of recommendations, and in following the recommendations, you have to insert multiple ELI ELs, or in the specific case it is 2 ELI ELs need to be inserted into the label stack, and that's shown in the bottom. You can read this better on the in the draft, I think. Yeah, next slide, please. So there are a few related discussions that have happened. One is regarding support of the hardware capability parameters, specifically the RLD, and whether it should be interface specific. Now we have considered several cases. It introduces a significant amount of complexity into the solution, and the benefits seem to be fairly minimal. And we really don't have a strong use case where we think it's worth the effort to actually go and do interface specific. And the second discussion that we've had is regarding OAM. Now the OAM requirements are still being formed in segment routing, and we are working with those authors. But the solution that we have recommended of using multiple ELI ELs is not expected to introduce new problems as yet. That's our thought right now. We don't think that it will introduce new OAM, new problems in existing OAM or new OAM requirements itself. So that's about it. Any questions, comments?
With regards to per interface, we got exactly the same comments in PC. So when you define how you exit your ingress router, you might have different label stacks. So if there's a valid use case, please let us know, because we are at the point we decide whether we do it per node or per interface /line card.
Right. Note that it is not that simple to make it per interface, because you have to model where exactly the entropy label is added, and it might be on a line card, it might be somewhere else.
So I didn't hear impossible. I heard not that simple. So give me a compelling use case if you want me to do all the work. Is that?
Yeah, that's right.
Other questions or comments? Thank you.
Thanks.
Hello, this is Eric, and this draft is for multi-topology segment in segment routing. Please. Okay, there's one new segment type was introduced here. It's called multi-topology segment routing, and also MT seed, and which is a IGP segment attached to an IGP topology, and it should be global within the SR domain, which indicate one specified topology. So this draft was try to propose this multi-topology segment for the SR network. Okay, and MTC was used to identify the specified topology. Okay, here's the use case for MRTFR. We all know MRT-FR routing was done by two disjoint redundant tree, which is called MRT blue and MRT red. In the MRT architecture document, the forwarding mechanism for IP network needed to do it in IP tunnel, which will introduce extra IP address. But with this empty seed, we can help to solve that problem. Okay, here's a forwarding mechanism for this draft. For example, in ingress router, the push operation need to be done when the PR found the fault. We need to push the corresponding MRT blue or MRT red seed into the packet. Then this seed can steering the packet along the alternate paths. On the transit router, we continue operation need to be done in and on the egress router, so the next operation can be done. Okay, this is about the control plan mechanism. For MRTFR, we believe IGP extension for this multi-topology segment need to be done, and this segment need to be unique within IGP domain. And when this segment was allocating, we recommend this segment was allocated in a centralized way. We didn't say distributed way is not working, but we recommend that is better. Okay, so how to exactly how to assign this segment? We can do it manually or just choosing the allocator automatically. The detail we can decide in future. Okay, here's the next step. We hope this is the first draft of this problem. We hope to collect some feedback on it and improve the draft. Okay, I'll leave some time for the questions.
So, Kiriti Kampala, I have a naive question. If you do multi-topology ISIs, why would you need multi-topology segment IDs?
Okay, here's we are not what we do is trying to solve MRT problem in the segment routing network.
Okay, so you're really saying MRT rather than multi-topology?
No, that is Robin from Huawei. It's easy to be clarified because current the IGP multi-topology, they always no header, no bit in the header can identify multi-topology. In the existing network, they recommend use the DSCP, but I think that does not work. So that we want to use the MPLS to all the segment to extend the IP header to identify multi-topology.
Didn't get it, but I'll read the draft.
Okay, yeah.
This is Hannes from Juniper. Actually, the segment routing design team has put in sufficient provisions in the IGP extensions for additional protocols, right? So when we assign all those indexes and label blocks, actually the right way to extend that over time would be to get a code point for MRT and then just use the existing label block and index machinery for doing that. What you try to do here, as far as I understand, is you force every packet into a double lookup just to key off to the correct topology, which might be a bit expensive on some hardware platforms.
Okay, thanks.
They agree with Hannes. It happens. I think, and to the point that Kiriti mentioned, in ASIS, everything is already provisioned for multi-topology, except one TLB. SD capability tier B. I think we need to just make it that one MT aware, but that's it.
So Kiriti again, just having a quick side discussion. What it looks like is you really want to do MRT, not really multi-topology. And you can do MRT calculations at the head end using existing SIDs and say this is my blue path and here's my blue label stack and here's my red path and here's my red label stack. And if you do the computations right, whether you do them or some centralized magic SDN controller does it, you will get disjoint paths, which is maybe what you want.
Okay, don't get me wrong. I didn't say.
So the idea actually, Chris Bowers, Juniper. The idea, Kiriti, is not to use a label stack to define the MRT path, but to simply have it be another algorithm. So currently, a SID is defined to follow the shortest path, that is computing the shortest path algorithm. Correct, a node SID. And so, correct. So 1 and 2, for example, could be red and blue, and you simply populate the forwarding entries for those algorithm SIDs.
Thanks.
Okay, and that's exactly on time, and that's a wrap, people. Thank you very much. We'll see you next time, and I think we'll have a lot to discuss on the list. Please forgive me that I have to run the board like right now. You might have a chance to. We need a right. We need a right. Doing that way. Your car. Fine. No, I mean I was just going to take.
You remember we had
I mean, we'll look at your email. You might have a chance to talk to Bruno. Maybe perfect. That'd be a good show.